नमस्कार दोस्तों, जय हिंद। Myself Yogendra Narayan Prajapati, assistant professor from Ajay Kumar Garg Engineering College, Ghaziabad. I am teaching computer organization and architecture. Uh, the most important topic of this subject is carry look ahead adder. Today I am going to teach this topic with the help of the circuit diagram and some important concept of the mathematical equation. First, I explain what is the carry look ahead adder. This is a kind of the adder produce carry propagation delay while performing the some arithmetic operation. When any adder perform the arithmetic operation or the multiplication operation or the division operation, it some kind of the produce carry propagation delay. With the help of the carry look ahead adder, we remove this propagation delay with the concept of the some mathematical equation. This is the major problem. This is the major problem for the adder, and hence improving the speed addition while they improve the speed of the other arithmetic operation. So with the help of the some mathematical equations, how to produce the carry, how to produce the previous carry or the next carry, we solve such kind of the problem that is known as the propagation delay. Hence, reduce the carry propagation delay of the address of the great importance feature of the carry look ahead adder. That is the main important feature of the carry look ahead adder to reduce the carry propagation delay. They are the different logic design. They are the different logic design approach that we have to employ to overcome the carry propagation delay problem. Carry look ahead adder, which is solve the problem by calculating the carry signals in advance. Now, with the help of the circuit diagram, I explain what different type of the delay are occurs and how we can calculate the advance carry. Suppose this full adder perform the arithmetic operation when this carry R work as an input. It means this full adder wait some time until this full adder R perform the arithmetic operation, until this full adder perform the arithmetic operation, until this full adder perform the arithmetic operation. It means this is the some delay to perform the this full adder. Similarly, this full adder also wait the some time to perform the arithmetic operation, or that or wait until he found the C2 carry. Similarly, this full adder also wait for the perform the some arithmetic operation until he does not found the C2 carry. It means there are the some propagation delay are occur to perform the some arithmetic operation. Now, this is the circuit diagram of the full adder. In the full adder, there are the two concepts, sum and carry. The sum is based on this circuit. Sum are designed simply the XOR gate, and the carry are designed with the help of the AND gate. This is the main way we found in advance in carry propagation delay. This is the block diagram of the full adder. That is the carry. This is the A0, B0. Now this is the sum, and this is the carry in, and that is the carry out. This is the block diagram of the this is the functional diagram of the full adder. Now this is the carry in, this is the carry out, this is the carry in, and now this is the carry out. Now here, if I advance calculate the C3 carry, then we implement the circuit diagram of the C3 carry here, then this full adder, no propagation delay. This is the main concept to design the carry Lookahead adder. Similarly, if we in advance we calculate the C2 carry, then there is the no delay for this full adder, then propagation delay is by default automatically removed. If we calculate this carry in advance, then the propagation delay of this full adder removed. This is the concept of the carry Lookahead adder. And any full adder, C in is given. It means the working of the first full adder is automatically performed. To find, to calculate the advance carry, we see the truth table of the full adder. How the full adder are designed. This is the circuit diagram of the full adder, and what is the truth? This is the two input A and B, or this is the carry input. Now this is the carry output, and this is the sum. This is the truth table of the full adder. If we analyze this carry, then we found how we calculate the advance carry. For this three condition, no carry are generated. Remaining this condition, carry are generated, but carry are depend upon the previous carry. Carry are depend, this is the carry output, this is the carry output, or this carry is depend upon its previous carry. That is the main propagation delay. And for these two conditions, carry are generated, and that is not dependent upon the previous carry. It means G stand for A, B. A XOR B, then carry are generated, and P stand for the propagation, and propagation is also depend upon the this and this, or this is the previous carry. It means that is the propagation delay is depend upon the input of A and B, and also depend upon the previous carry. This is the main mathematical function by which we find the advance carry, and this circuit are implement into this circuit here, here, here. We advance calculate the C1, C2 and C3 and implemented here, by which remove the propagation delay. Now, how find the advance carry? They are the some concept. For example, Gi, that is known as the carry generator, or that is known as the A XOR B. And what is the Pi? That is the propagation delay, that is known as the A XOR B and Cn minus 1. This is the main two concept by which we can find the advance carry of the every full adder. Now this is the carry, this is the advance carry, that is Ci is equal to Gi plus Pi and Ci minus 1. If this is the advance carry, if we found the C1, then C1 is equal to, that is Z1 plus P1 and plus C0. If this C1 implemented in this circuit from here, then the propagation delay of this full adder are automatically removed. With the help of this concept, we can also calculate the value of the C2. Now, what is the value of the C2? That is the G2 plus P2 and plus C1. That is the value of the C2. Here, the value of the C1 we put from equation number 1 in equation number 2. What is the value of the C1? The value of the C1 is G1 plus P1 C0. This value we substitute in this equation. Now we find the value of the C2, that is G2 plus P2. What is the value of the C1? G1, P1 and C0. Now we directly calculate the value of the C2, and the value of C2 are implemented here, by which the carry propagation delay are removed advance. Now when we solve this equation, then find out the value of the C2, that is G2 plus P2 G1 plus P1 C0 and P2. That is the value of the C2, and that value are implemented here. Then the carry propagation delay for this full adder are automatically removed. Similarly, we find the value of the C3 directly, by which we can remove the carry propagation delay of this full adder. Then how can we find the value of the C3? The value of the C3 is depend upon the value of the C2, C1 and C0. It means the value of the C3 is depend upon its previous three value. Now by the equation, here we find the value of the C1, here we find out the value of the C2. Then in the next part we calculate the value of the C3. Now the value of the C3, what is the formula? C3, that is the P3 the value of the C3, that is the G3 plus P3 and C2. Then we substitute the value of C2 in this equation number 3 with the help of the equation number, this equation. Here we find the value of the C2, this value we substitute in this equation, then we find the value of the C2. Now G3 plus P3, what is the value of the C2? That is the G2 plus P2 G1, P1, P2 and C0. Now this is the value of the C3. When we solve this equation, then we find the value of the C3. Now that is G3 plus P3 G2 plus P3 P2 G1 plus P3 P1 P2 and C0. Now this value, that is known as the C3. If with this value we directly implement in this circuit here, then the carry propagation delay for this full adder is removed. That is the main concept. Yeah, this is the main objective of this circuit diagram, to remove the all the propagation delay by the help of the calculating the advanced carry, that is C3, C2, C1 and C0. So, with the help of this mathematical equation, equation 1, equation 2 and equation 3, we advance calculation of these 3 carry, and we implement in this circuit diagram. C1 here, the circuit diagram of the C1, C2 the circuit diagram of the C2, C3 the circuit diagram of the C3. Similarly, we can also calculate the value of the C3, the value of the C3, the value of the C4, that is the C4 here, that is the G4 plus P4 and that is the C3, that is the value of the C4, and we can calculate in advance the value of the C4 by, so that we can remove the propagation delay for the next full adder. So, this is the main concept for this carry Lookahead adder. These are the some advantages of the carry Lookahead adder. We have already explained the main advantage of this carry Lookahead adder, that is the to reduce the propagation carry for the each full adder. It provides, if we remove the carry propagation delay, then automatically the speed of the full adder are the fastest. These are the main 2 advantages. Now, there are the some disadvantages of the carry Lookahead adder. For designing carry Lookahead adder, it is very complicated circuit diagram to increase the variable and to increase the variables. C1, C2, P0, these are the some variables are increased. This circuit diagram are very complicated. So, this circuit diagram are very costly in the term of the hardware, but the main advantage of this carry Lookahead adder to remove the delay and to increase the fastest speed for the all the operation. There are some disadvantages, it does not matter, but the main advantage to remove the carry Lookahead adder. Thank you to all. We meet the next classes for the next new interesting topic for the computer architecture.